Hi all, today we are going to speak about the cosine similarity. So hope you all know about what is cosine similarity in the context of natural language processing. In the context of natural language processing, say if you have two different documents, then you have to find out the similarity between these two documents, right? So for that, the first thing which you have to do is that you have to make a word table. Say if you want, you can do the pre-processing. If you don't want, you don't have to do the pre-processing. But if you're doing the pre-processing, normally that's a step that we have followed, and we will find out, say, for each word the best data science course, okay, and then data science is basically already there, so we are actually taking is and popular. So these are the various words. So what is the occurrence of each of these words on each of the documents against each of the documents, right? Then we have to find out then we have to apply the formula. So this is the formula which is actually similarity between two different documents is actually cos theta. So A dot B divided by magnitude of A into magnitude of B. So theta is basically the angle between the vectors. This mode A is basically calculated as this is the magnitude. It is actually root of A1 square. So if you are actually following Euclidean distance, you can actually A1 square plus A2 square plus etc. right? So this is how you will basically follow the this is nothing but your formula for cosine similarity. So in this case also you are actually finding out the occurrence of each and every term against the documents, right? Then you are actually doing the d1 dot d2. Then you have to find out the magnitude is actually done by root of 1 square plus that is actually done for each of the documents. So you will be applying this particular formula and you are getting a value of 0.44721. So this is basically the similarity, okay, the similarity between these two documents. If you want to find out the theta, the angle between these two vectors, you can actually find that also. So main thing which you have to identify or understand is that the similarity has to be between -1 and +1. Alright, so if a value which is more closer to 1 comes, that means that they are more related to each other, they are more similar to each other. And if it is away from each other, or if it is closer to -1, then you should understand that it is less related to each other, right? So this is the similarity value. This is how actually you will find out the similarity, cosine similarity between two different documents in the context of natural language processing. Now we will try to put this exactly, and we will see how we can actually proceed this in as a demo. While implementing this, how we will do that. So for that we are actually using this this example, and I have actually put this in the LinkedIn, in the GitHub as well. So the first one is basically by developing a particular function by using the Python, okay. So this is the basic form of using it, and normally I will not recommend anybody using this, because this is the minimal way. So I mean, like, we are just exactly converting the formula into the program, okay. So we are actually finding out the cosine similarity between two numbers, and if the length is not equal to y, because here the main thing which you have to keep in mind is that your length has to be x and y. If you have two different documents, both of their length has to be similar, and then you have to return null, or you can actually also print something like, the length has to be same or something like that. Else what you have to do is that you have to compute. You are computing the dot product, then you are finding out the magnitude, then you are actually dot product divided by magnitude, and you are returning it, right? So this is how your cosine similarity is. Say, just imagine that these are the two different lines, and you are making it into a corpus, and then you are actually finding out so from the Sklearn package you are actually using this count vectorizer, because we have to convert everything into a vector. So for that, in order to vectorize, you are actually using this count vectorizer function, and fit.transform is the one which you will apply the model. So you are applying the model upon this corpus. So this is the corpus, you are applying it upon the corpus, right? And then you are actually finding the cosine similarity. So cosine similarity, you are just passing it as two different documents. So first one, 0 to this one, is your first document, second document, like that you are actually passing the documents. So here you will be able to identify the similarity between each and every document. So 1 and 2, 2, 1 and 3, 2 and 3, everything you will be able to. So cosine similarity between these two documents is 0.68, the other two documents is 0.21, 0.27. So you can understand that the similarity between your document 1 and document 2 is almost like 68%. So it's not bad, right? So this is how you will actually identify one. So we use the count vectorizer, and the second one is basically by using the in Sklearn itself, they have this function called cosine similarity. So we are just directly using this function called cosine similarity from Sklearn. The previous program, we actually tried to use it. We developed the function and we used it. So that is also it's customizable. You can actually do it in the way you want. If you want to use directly from Sklearn, which is the cosine similarity function, which is already there, you can import it first, and then you are actually passing the values over to the cosine similarity. Then you can calculate. Then you could also see that the results between 1 and 1 is basically 1. Both of them are actually, so this means that these two documents are actually similar to each other. Then document 1, so here it is 1 and 2, 1 and 2, yes, and 2 and 1. So like that, it's 0.68%. So this is one thing which you have to understand. And then the next one is basically by using the NLTK package. So for that we need stop words and tokenizing and everything. So these are the two different documents which you have, and you are actually downloading the Pinkett package. So it's for the tokenizing and all this removal of this thing and everything, and you are actually tokenizing the words. So when you tokenize, this is the sentence, right? So the sentence, I love horror movies, so I love horror movies, so it is actually tokenized. And then you are downloading the stop words, and then SW is basically, it contains all the stop words in English, right? And you are actually creating two different separate lists, L1 and L2, with an empty list, and then you are creating the set for X and Y. So for each word W in X list, if not in, then what you have to do is that you have to actually put in the X set. So your X set will have one, I love horror movie. So you have your X set and Y set, which contains the details. And then you are actually vectorizing it by using a function called X set union of Y set. Then you are actually vectorizing it in this way. So you are actually appending it to the L1 and appending it to the L2. You are creating a vector and putting it into the L1. Okay. So when you finally look at the L1, you could see that 1, 2, 3, 4. I mean, like, you will get all these values. Okay. And now what you have to do is that you are actually ranging, you are going through the each and every vector, and you are actually doing L1 into L2, and you are doing this operation. This is your cosine similarity operation basically. So when you when you find out the cosine similarity between these two articles, it is actually very poor. It is only 0.28, right? So this was, you have to understand there are different ways of using the or implementing the cosine similarity. You can write your own function. You can use a cosine similarity function from Sklearn, or you can also use the NLTK package and make it work for you, like the cosine similarity function. So these are other different ways in which you can actually use a cosine similarity. So basically cosine similarity functions will help you to identify how much similar each of the document is against to each other. Okay, so hope you understood how it works, and make your hands dirty and try. And if you have any doubts or confusions or any import errors or anything like that, please let me know. I'll try to help you in the chat section. Thank you so much.